Okay, I've had some questions about the tip or slip project, and I made this quick video to hopefully answer these questions. So first of all, let's take a look at the block that you're using, and hopefully you see the 6 orientations, and given a rectangular block, you can figure out which orientation we're talking about. So notice the ones that are flattest, okay? The flattest ones are the most stable, and they should hopefully slip, all right? Now there's some chance if you have a really sticky surface that's not very smooth, you might find that not all the orientations have the block where they will slip. All right, they might always tip. All right, so if that's the case, you need a smoother surface. All right, so the whole idea here is to take the block, tilt the surface until this thing starts to slip. You can use your phone to measure the angle. You can use a protractor. There's all kinds of ways you can do that. Find that angle and take the tangent of that angle, and you'd get the coefficient of friction. So there's a video that explains how that all works. All right, so if you do this for orientations 1, 5, and 6, you probably have 3 different angles because things aren't perfect. All models are wrong. Some are useful. This is still a useful model, even if it doesn't give you the same angle every time. All right, so there's some variation that you'll get, and so just take the 3 angles, take the tangent of each, all right, and you'll get 3 estimates of the coefficient of friction. Average those together, and that's what you'll use to fill out the spreadsheet. Okay, so next, let's take a look at that spreadsheet. All right, so here's the spreadsheet. Let me get rid of the numbers so I can talk to you about how I came up with these. Okay, so if you have average those numbers together, right, you have a coefficient of friction, then your predicted slip angle is just going to be the arctangent of that number. Okay, so maybe that turned out to be 30 degrees. All right, probably not, but I'm just making up a number. So no matter what the orientation, the slip angle, the predicted slip angle is the same. So you take that average number, do the arctangent, and you get the predicted slip angle. Okay, the tip angle, though, depends on the orientation. So orientation 1 is pretty stable, all right? So the tip angle would probably be higher than the slip angle, all right? So maybe it's 45 degrees, all right? Then you do your experiment, all right? Let's do the experiment, and let's say it comes pretty close to the predicted slip angle. It never reached the predicted tip angle because it started slipping before it tipped. All right, so there's no answer, this is not applicable because it didn't actually tip. All right, so we look at this data, and what it's telling us that since it slipped, and the slip angle is smaller than the predicted tip angle, then what we predicted was that this thing is going to slip. So yes, it's a match between the predicted and what actually happened. Okay, so that's what the match column is about. All right, so here's what could go wrong. Let's say that we had an orientation where the tip angle is pretty close to the slip angle. Maybe it's 34 degrees. Okay. All right. So it could be that this is still predicting that it's going to slip because this angle is smaller than this angle. Well, let's say things happened and the actual angle that it slipped was, it actually tipped before it slipped, so maybe it tips at 32 degrees. Okay, you can't record a slip angle because it didn't slip, it tipped. Okay, and so in this case, we would have predicted a slip because this angle is smaller than this angle. But what we actually got is a tip. We record the data there, and this is not applicable because it tipped before it slipped. So in this case, there would not be a match. Okay, so hopefully that clears up what I want for every person on your team. You can fill out this small little table. All right, so there you go. Email me if you still have questions. Thanks.